In this video, we will learn about adjustment of pitch and frequency in musical instruments. As we know that if we can control the frequency, we can control the pitch. So first, in wind instruments. Now flute, shahnaai or whistle, etc. are musical instruments in which air inside a pipe is set into vibration by blowing air using our mouth and lips. So this is the way of blowing air through a flute. In a wind instrument, frequency depends on the length of vibrating air column. As we know that the frequency of vibration is inversely proportional with the length of the air column. So smaller the length of the air column, higher is the frequency and higher is the pitch. So that means pitch, as we know, it is proportional with frequency, so pitch is also inversely proportional with the length of the air column. The shrillness of sound increases on reducing the length of vibrating air column. In a flute, there are a number of holes in the pipe along its length. So these are the holes. When all the holes are closed using our fingers, the length of air column is maximum equal to the length of the pipe, and frequency of the sound is minimum, or sound produced is a flat sound. As we know that if the frequency is less, then pitch of the sound will be less and we get a flat sound. However, if the hole is opened by removing the finger, the effective length of column decreases and consequently frequency of sound increases and also pitch of the sound increases. We get shriller sound. The flute player can therefore adjust the pitch by opening or closing different holes of the flute. Then, in stringed instruments, piano, sitar, violin, guitar, veena, etc. are the examples of stringed music instruments. So this is a guitar, this is a violin. In such string instruments, several metallic strings are taken which are of different material, say stainless steel, brass or copper, and are of different thickness. Moreover, the tension in the string can also be changed. The frequency of vibration depends on density, thickness, tension, and length of the string. Frequency is more for a thin wire and less for a thick wire. So, we can see that here these are the keys of guitar and these are used to change the tension of the strings. Again, frequency increases on increasing the tension and on reducing the vibrating length. Thus, by vibrating different strings, the player can change the frequency and thus is able to control the pitch of sound produced. Moreover, if the player plucks the string at the middle, frequency is less. So, if the string is plucked in the middle, so this is less frequency or less pitch. On plucking the string near the ends, that means if the player plucks the string over here, so the frequency increases. So we can say this will be high pitch sound is produced. In membrane instruments, dholak, tabla, drum, bonga, etc. are examples of membrane instruments. In these instruments, there is a membrane which is stressed and tension on the membrane can be changed by means of strings because of the strings can be tightened either by use of metal rings or nuts. So in case of tabla, so this is the membrane and this is the string. So by these strings, the tension of the stressed membranes can be adjusted. When the stressed membrane is made to vibrate by striking it with a hammer or tapping it with hands, sound is produced. So to produce sound, we have to strike this membrane. The frequency and hence pitch of the sound produced depends on the size and tension of the membrane. If the size of the membrane is small and tension on the string is more, a sound of higher frequency is produced and consequently shriller sound is produced. That means if the size of the membrane is small and tension is high, then frequency increases and accordingly the pitch increases. So we get similar sound. Now let's discuss monotone. A sound produced by a particular musical instrument is usually called a tone. A sound of single frequency is called a monotone. Thus, a monotone means a pure sound of single frequency. We use a tuning fork to produce a monotone. In fact, a tuning fork is only device which can produce a sound of single frequency. A tuning fork is a U-shaped metallic device which consists of a handle or stem and two tines or prongs. So this is the stem or handle and these are the prongs, and this is a tuning fork. Now, two prongs are joined with the stem and to form a U shape. When one of the prongs of tuning fork is gently hit with a rubber hammer or pad, the prongs start vibrating. The back and forth vibrations or to and fro vibrations of the prongs produce a sound. Now, the frequency of vibration of a tuning fork depends on the material of tuning and dimensions of the prongs and is independent of any other factor. The frequency of monotone produced by a tuning fork is engraved on it. Generally, tuning forks of frequencies 256, 288, 320, 342, 384, 426, 480 and 512 Hz are available in school laboratories. So the frequency is engraved on the tuning fork. I hope this topic is clear to you. Thank you.